Welcome. This session we'll talk about the flexibility and the stiffness properties in a structure. You know how these two terms are very important, okay, in terms of matrix methods of analysis. So, in your undergraduate course, everybody might have undergone the courses like Introduction to Matrix Methods and all. So, the very first method in matrix methods of analysis is flexibility matrix method and then stiffness matrix method. So these two things will be introduced to you in undergraduate level. So if you want to understand those two methods, you need to know what is exactly the flexibility and stiffness. Okay, so first let us talk about what is flexibility. Okay, I start from a axially loaded bar in a simple way to understand. This is the most simple way to understand what is flexibility. So this is the axial load applied on a bar. Okay. So let this be the deformation. Okay. Let us call it as delta. So this, you know it, like when a bar is applied by an axial load, there will be deformation. If it is tensile force, you will have elongation. If you have compression, you will have the compressive force will induce the contraction in the member. So you have studied in your UG that delta is equal to the deformation PL by EAE. Okay. Now just rearrange this term delta, send this P to the left hand side, which is equal to L by A. So this is called flexibility value. Okay. Now let us understand what is exactly this. If you say this load is 1 unit, okay, if P is equal to 1 unit, then F will be equal to delta. This is how you can define flexibility. So now let us define what is flexibility. The deformation produced deformation produced in a deformable body in a deformable body under unit force is called flexibility. Okay, so this is how you define flexibility. The deformation produced in a deformable body, this is a deformable body, under unit force. If P is equal to 1, the delta will be equal to F flexibility. Okay, the deformation will be equal to flexibility. This is how you define flexibility. Okay, and how you measure it, the value is L by AE in case of axially loaded bar. Okay, now let us talk about stiffness. Right. So what is stiffness and how you define it? Again, I go back to the deflection in an axially loaded bar, PL by AE. Okay. So now you rearrange the terms, take delta to the right hand side. So P by delta is equal to, it will become AE by L. Okay. Now this is the stiffness value. Okay. Now again, how you define it? So if you say if delta is equal to 1, then stiffness will be equal to the load value. Okay. So your definition starts from here. Okay. Now, how you define it? The stiffness is nothing but the load required to produce unit deformation in a deformable body. Okay. And the inherent meaning here is the load and the deformation shall be in the same direction. That I am not including in this definition. If you want, you can write in direction the load. Okay, that you can do, right? So this is how you define the flexibility and the stiffness. Okay, so this way you can understand the flexibility matrix method and stiffness matrix method in a better way if you know these two definitions, or if you can understand these two definitions, okay, in a better way, right? Okay, thank you.